65 now. So we're starting a new chapter now, and this worksheet is actually quite easy now if you've done trigonometry before especially. But it's really just revision of the basic ideas of trigonometry. But before we go into sine, cos and tan, we just need to talk a little bit about angles. And there's two ways to measure angles. One is using degrees. Yes? Yes. And the other one, does anyone know? Is radians. Now, when it comes to degrees, how much makes up one circle? 360 degrees. And when it comes to radians?
2 pi.
2 pi radians. For the moment, it's enough for me to say that all you're doing here is like changing the unit. You know, you can measure distance in meters, centimeters, kilometers, inches, feet, etc. So, likewise, you can measure angles in degrees or in radians. 360 degrees represents 2 pi radians. If you want to convert, here's the rule to convert. If you want to go from degree to radians, you multiply by pi over 180. And if you want to go from radians to degrees, you multiply by 180 over pi. And it's as simple as that. That's the way to convert. Now, later we'll talk a bit more about the importance of radians and what they can be used for. But for the moment, like I said, I'm just saying radians are a different unit, a different way to measure degrees. And if you want a rough conversion in your head, 1 radian is roughly, well, does anybody know?
1.3.
No? 1 radian is roughly how many degrees?
186.
No.
1 radian?
No.
180.
No.
Okay,
Don't type it in. I want to see if you know it in your head. 1 radian is roughly 58 degrees. Okay? Roughly 58 degrees. Okay? So if somebody said to you, measure out 1 radian in an angle, it's roughly 58 degrees, roughly. Okay? That's just to help you picture how big a radian is. So you might say, why would you use a radian? Because radians are really big. It's difficult to measure then. Why not use degrees? Does anybody know the advantage radians have over degrees? No? Well, the reason is when we come to calculus and when we come to studying more about circles, we'll find that the radian unit is much more convenient for formulas. That's the real reason, okay? But like I said, for the moment, it's just a different unit. So you tell me, using your calculator, 1a, turn 33 degrees into radians. Tell me it as a fraction and as a decimal. Come on, I want to see typing. So, your 33 degrees in radians is what?
11 over 60 pi.
11 over 60 pi, or as a decimal? 0.575 radians.
0 and then 75, right? That's, is there a way we write it?
No, in fact, no, and that's important too. Yeah, I'll talk about that in a moment, okay? But how to write that, yeah. Well, actually, I'll show you now. So, Hadil, what would you say the answer was? 33 degrees is
11 over 60 pi.
11 over 60 pi. Now, please listen carefully. This is one of these things that people forget in the exam, and it costs them 1 mark, and it doesn't need to cost you 1 mark. So look very closely. If there is a little circle like this, it means the unit is degrees. Happy? If there is no mention of a degree or a circle, it automatically makes it radians. So it's not necessary for me to say radians here. The fact that the degree symbol is absent is enough. Just like that. So what is this in decimals?
0.5.
0.575. And some people write radians, but like I said, it is not necessary, because again, the absence of the degree symbol automatically makes it radians. Okay? And I know I've said this twice, and I could say it 2 more times, but come the exam, somebody, more than one person, will forget this. Their answer will be slightly wrong, and they'll lose 1 mark. And you don't have to lose 1 mark here. Okay? So, one more time. If the degree symbol is there, funny enough, it's degrees. And if the degree symbol is not there, funny enough, it's not degrees, it's automatically radians. Okay? Can't make it any simpler than that. Now, 2a. So 2a is in radians. I want you to tell me now what it is in degrees. So calculator time again.
Six.
96 degrees. Is that right, yes?
Yes.
And then one more, 2p. P. Tell me what that is. 2p is 2.7576 radians is... Yes?
157.99.
So 158 we'll say.
Yeah.
Degrees. Now look, this comes up in the exam frequently enough. It's usually 1 or 2 marks, and it should be the easiest 2 marks of your life. Okay? All you need to do, it's not in the formula book, all you need to do is remember this rule. Degree to radians, multiply by pi over 180. Radians to degree, multiply 180 over pi. It's all you need to remember, and you've got 2 marks. Okay. There should be no questions here. So I'll go on to 3. The triangle ABC is a right angle triangle, and the right angle is at C. So,
What?
3.
3A?
Yes, ABC is a right angle triangle, and the right angle is at C. A to C is 324 units. A to B is 405 units. So I am looking for the missing side, which is X. And our good old friend, who will help us here? That's right, Pythagoras will help us here. So we've got 324 squared plus x squared equals 405 squared. And take out the calculator and give me the x here. Square root 405 squared minus 324 squared. The physics students already have done this with Stephen B and me. You've done it twice, okay? So what's x?
59049.
Did you take the square root? No.
243.
2, 4, 3.
You wrote 1.
Sorry, well, 2, 4, 3. I think you learned about Pythagoras when you were 12 years old, so I mean, I'll assume you've seen Pythagoras' theorem before. Yep. Okay. And lastly now, 4a, exactly the same as 3a, but I give you a triangle in case you don't know what a triangle looks like. So there you go, triangle. No, actually it's not exactly the same. What's different in 4a here?
We will use degree.
What's different in 4a here?
You have an angle.
You have the angles. How many sides do you have? Well, you only know one side, but you have two angles
And the right.
and a right angle. So you know all the angles. All the angles are known. Only one of the sides are known. And I want the side that's missing, which here is x. Now, we have to use something different here. Not Pythagoras, but something else. Does anybody know? Sine, cos, or tan. Alright? So, do you remember the definitions? Sine is opposite over hypotenuse. Cosine? Not adjacent over hypotenuse. And tan? Opposite over adjacent. So, if I look at, say, this angle here, is this the opposite of the adjacent or the hypotenuse? This is the opposite. This side here is the adjacent, and this side here is called the hypotenuse. And for those people who have seen it before, if you need help remembering, have you seen this one in high school? Some have, some haven't. Well, this is how it's done in Europe, at least, anyways. So sine. Oh, sorry. Sakatoa. Yeah. So sine is opposite over hypotenuse. Cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. Okay. I'm sure, I don't know, you've done this in high school and you might have learned different ways to remember it. So I don't know if there's some like sentence that you say. Is there? Is there one? You just say Sakatoa? Is there an Arabic sentence? Yeah? That only works if in Arabic sine still sounds like sine, does it?
Yeah, get the
Does it?
signs again.
Oh, that doesn't sound like sine. Cosine?
Get the
Tangent?
Za.
We'll stick with sine, cos, and tan. Okay, so which two sides are I'm talking about here? Opposite and hypotenuse. So which of the three do I need? Sine, cos, or tan? Sine, yeah. So sine, what angle? 34. What will that equal? Come on.
Opposite.
Yeah, which is here what?
0.55.
No, focus. Come on. No. I want to know what fraction do I write here? Opposite over hypotenuse. So what do I? X over 289. Right. So what's sine 34 now, Sadiq? You were saying?
0.559.
5592 equals x over 289. So now you can tell me what the x is, please. What is it? 161.6. Now I don't know if I rounded off. Let me check. No, I don't round it off, so I'll just leave a 161. Sorry, I don't include the decimal. Right, now, I hope that's okay, but just as a really quick revision, okay, there's your triangle, and this is the opposite, this is the angle here, this is the adjacent, and this is the hypotenuse. So you have sine A is opposite over hypotenuse, cos A is adjacent over hypotenuse, and tan A equals opposite over adjacent. So you see, this works perfectly like here, when I give you the angles but you're missing a side. Okay, so you can't use Pythagoras here, you have to use sine, cos, or tan. Notice how in one of the questions I don't give you the angle. I'm going to do that next. I'm going to do 4C now. No, actually 4B will do.